till yesterday you have learned major concepts of hyperbola. We have learned all fundamental definitions, we have learned all standard forms, we have also learned all characteristics, and then we also learned asymptotes in depth. So, we were learning some concepts of tangents and normals. Today we will complete them and we will try to solve some problems on them. Okay. Can we proceed? So, when it comes to equation of tangent, we have learned how to calculate equation of tangent at a point. At a point means point is on the hyperbola. So, here when we take this equation s1 equal to 0 and the point here x1 comma y1 is on the hyperbola, that is why we use the word at. Okay. So, whenever at a point word is used, you have to understand that the point is on the curve. Okay. So, then s1 equal to 0 becomes the equation. We have also learned the pattern of this, it is common for all curves. And when we substituted the parametric point for x1 and y1, we got this equation which is the parametric form of tangent. And also we tried to relate these with the normals. So, today here first we will complete all concepts of tangents and then we will move on to the concepts of normals. Now, we stopped at this slide. So, if y equal to mx plus c is a tangent of s equal to 0, then this must be comparable to the parametric form. So, when we compare these two forms, we can get sec theta and tan theta directly. Okay. So, this is basically the comparison. So, from here we are going to get sec theta is equal to minus am by c, and similarly we are going to get tan theta as minus b by c. So, now when we apply sec square theta minus tan square theta equal to 1, we are going to get minus am by c whole square minus b by c whole square equal to 1. So, which will give us the condition which is already given here, which is c square equal to a square m square minus b square. Now, is this the only way of deriving c square? Is this the only way? No, there is also a different way which comes from the idea of solving line and the curve. For example, here if we take this y equal to mx plus c and substitute this in the equation, suppose directly if I substitute this for y, what do I get? X square by a square minus mx plus c whole square by b square equal to 1. So, here I am going to get one quadratic equation in terms of x. So, when I solve this, I am supposed to get two solutions of x. So, if I get two solutions, it means the line is a chord. If I get only one solution, it means the line is a tangent. So, I will put delta equal to 0 here. When I simplify this, I am going to get the same condition which we have derived here using a different idea. Okay. So, this way also we can find the condition for tangency. So, that is what we have precisely written here. Now, to get this condition, the method is not unique, there are other methods also, you can explore them. Okay. So, now coming to the other form. If I put this condition directly in this y equal to mx plus c, then I will get the slope form of tangent, which can be written in this form. Okay. Now, if I want to find out the point of contact, then I can directly use this formula to find the point of contact. But you know our approach. So, we try to minimize the memory part, we try to maximize the alert part, we try to maximize the idea part. Okay. So, you do not have to remember every formula, as in when time comes and as in when it is required, you can derive it, you can solve it without using the formula also. Okay. But by directly comparing, by substituting this sec theta and tan theta in this a sec theta b tan theta, we can get the point as minus a square by c into m minus b square by c. Okay. So, this way also we can find the point. Okay. So, now it is not just for this y equal to mx plus c line, we can also do it for general line like this. Okay. So, before that, if you want to make a note, definitely make a note. Of this page also. Okay. So, now for general line also we can find the condition in the same lines. Okay. So, what do we do here? We directly compare this with a sec theta, sorry, x by a sec theta minus y by b tan theta minus 1 equal to 0. We try to compare these two directly and then we derive the condition in the same lines. Or the other method is to directly convert this into y equal to mx plus c form. So, what do we get here? My equal to minus Lx minus n. So, y will become minus L by m into x minus n by m. So, here we have slope, here we have c. So, directly we can substitute this in the earlier condition and get the condition for tangent c. That is simple. Now, also similarly here we can just put this in place of m here and we can put this in place of c here and get the point also. Okay. So, but here this is to be treated as a problem and to be solved by you. Do not take this as a theory point, take this as a problem and try to solve it. And again I keep saying, do not remember this formula, we have to learn the methods, not the formulae. Okay. Come on, make a note of this also. Okay. So, can we move on now? So, next is tangents through any point. Suppose a point is given, we do not know whether the point is on the hyperbola or inside or outside. How do we check? We have the idea of checking the location of a point with respect to hyperbola. But if you, let us say, realize that the point is not on the hyperbola, then how do we calculate tangents through that point? For that there are two methods. One is, if you want the combined form of the tangents. Combined form means the form will come in terms of pair of straight lines form. That means it should be a second degree equation. That can be obtained by using this formula. This is a standard formula of pair of tangents which is valid for all curves including circle. Okay. Circle, parabola, ellipse, hyperbola, for everything this is valid. But what if you want separated forms? Because every time handling a pair of straight line is going to be algebraically lengthy task, because the equation is too long and simplification also will be too long. So, for that there is a different method. So, you can learn this algorithm. From the parabola chapter itself, I have been doing the same method. Also from circles, I think I have been doing the same method. You can learn this method and try to apply. So, what is the idea? Put the point in slope form. So, we already know the slope form, just put the point there and solve for values of m. So, when we put point and solve for m, we will be getting a quadratic equation. So, when we solve for m, we will get two values of m. Now, after getting the values of m, if we put them back in the equation, we will be getting equations of tangents. But there could be a slight confusion. For example, if you take the form as y equal to mx plus minus root of a square m square minus b square. Let us say you have taken this as the tangent. Now, if you put point in this, what do we get? So, let us say I take the point as x1 comma y1. So, what do I get here? y1 minus mx1, basically I have taken this mx term to LHS, equal to plus minus root of a square m square minus b square. Now, when I square this, I will get y1 minus mx1 whole square equal to a square m square minus b square. Now, if I convert this into a simple quadratic equation, what do I get? I get m square into y1 square minus a square minus 2x1 y1 into m plus, these are the constant terms, okay, sorry, this must be x1 square minus a square. So, plus y1 square plus b square equal to 0. This becomes the quadratic equation in terms of m. After this, I will get the values of m. Now, after I get the values of m, if I substitute the values back in this equation, there is a confusion of plus minus sign. There are already two values of m here. If I put those two values here, I may get 4 tangents, but through any point which is external, we can get only 2 tangents. So, that means where is the mistake? Mistake is with the plus minus sign. So, whenever there is a confusion like that, after you get the values of slopes, you can also use the form of slope point form of straight line. Okay. So, which goes something like y minus, what is the point? y1 equal to m into x minus x1. By applying this formula, you can get the equations of tangents after you get the slopes. So, this way we can find separate tangents through any given point. Okay, so, this is the algorithm and you need to make a note of this algorithm and you need to practice this algorithm. Okay. Come on, make a note of this. So, also we can also learn this as a point. Okay. This must be given in one of the books. So, that is why I have mentioned here, but you need not remember this. Okay. So, here it says the slopes of tangents through this point are always roots of this equation, and if you recall, it is the same equation as we have derived here. Okay. So, if you just remember this method, it is sufficient, you do not even have to remember the forms. Okay. Can we move on now? So, the next concept is director circle. So, here I am going to derive the director circle directly based on the definition of it. But before we proceed, we have to choose some methods. So, now let us look at the definition first and then we will solve for the equation. So, definition says it is the locus of point of intersection of two perpendicular tangents of the given curve, or locus of a point from which two perpendicular tangents can always be drawn to the given curve. Now, given curve can be any curve. So, here it can be circle, parabola, ellipse, hyperbola, but for every curve director circle exists and it may have some equation. So, now coming to this, how do we solve this problem? So, here if you notice, the point from where two tangents are drawn, where two tangents are perpendicular, that point must be exterior to the curve. So, that means point is outside the curve. So, what is the best way of finding tangents through outside point? There are two methods. One is pair of straight lines form, other is the independent or separate form. So, let us apply POSL form first and then we will learn the other method. So, method number 1. So, we are going to use POSL form. Okay. So, you need to learn both methods. So, I am solving using both methods, and also while simplifying you need to smartly check only the terms that you need. So, that is why I am solving this, just to show you how you will do that. Okay. So, what is the equation of tangents if the point is, let us say, h comma k. So, basically I have taken the locus point as h comma k. So, what will be the equation of tangents? It will be SS11 equal to S1 square, and we are taking the hyperbola in the standard form. So, what do we get here? X square by a square minus y square by b square minus 1. This is my S, and then h square by a square minus k square by b square minus 1. This is S11 and equal to, we need S1 here, which is xh by a square minus yk by b square minus 1 whole square. So now just by looking at this itself, the equation has become lengthy, but we do not have to simplify it completely. So whenever you get POSL form, do not blindly simplify it, do not do that. Look at the condition, what is required here? We want the lines to be perpendicular, we want the tangents to be perpendicular. So that means M1 M2 must be minus 1, but here there is no M1 M2 directly. Now again recall the concept of POSL. How do we identify whether a POSL is going to be perpendicular or not? By checking coefficient of x square plus coefficient of y square is 0 or not. Okay. So here we are basically interested in only coefficients of x square and y square, not other terms. So what do we do here? We only collect those terms. So we want coefficient of x square plus coefficient of y square to be 0. So let us collect all the terms. Now here when there is this x square term, when this term multiplies this entire constant, because this S11 is constant, then we will get x square here, and here when we apply a plus b plus c whole square. So when I am squaring this first term, only then I will get the x square. So I will collect only x square like that. Okay. So here if I take x square by a square here, okay, into this constant term, so h square by a square minus k square by b square minus 1, and from here also I am going to get 1 x square. So what will be that term? Minus x square into h square by a power 4. This is the x square term that I am getting from the entire equation, because I have taken the RHS also to the LHS. Now but I am interested only in the coefficient, so I will remove x square from here. Okay, so I will write 1 here. Okay. So now similarly I will also write the coefficient of y square. So how do we do that? In the same manner. So there is minus sign here, so it becomes minus 1 by b square into, what is the term here? H square by a square minus k square by b square minus 1, and there will be one more y square term from RHS. So this term when squared will give us y square. So what is the square of that coefficient? That will be minus k square by b power 4, and this entire sum must be equal to 0. So here if you observe, what we have done is, we have collected basically the coefficient of x square, which is this term, and coefficient of y square, which is this term. So again if you notice, the terms are lengthy, of course they are, but they look like lengthy, but they are actually easy terms only. So how do we proceed? We simplify and see if there are any terms which can get cancelled. Okay. So let us just simplify them. So here we are getting h square by a power 4 minus k square by a square b square and minus 1 by a square, right, 1 by a square, and there is one term here which is minus h square by a power 4 plus this is one single term which is the coefficient of x square, and similarly here minus h square by a square b square, this is one term, and what else, plus k square by b power 4 minus 1 by b square, right, plus 1 by b square, okay, and minus k square by b power 4, this must be equal to 0. Now see if there are any terms which can get cancelled. So here this h square by a power 4 is getting cancelled, this k square by b power 4 is also getting cancelled. From the remaining terms, take all variable terms to one side and constants to the other side. So what do we get? I am basically taking this term and also this term to RHS. So basically it becomes h square plus k square by a square into b square is equal to minus 1 by a square plus 1 by b square. So, this will turn out to be a square minus b square by a square into b square. So, now when I cancel the denominator, what do I get? H square minus k square is equal to a square minus b square. So, now what is the end step? In place of h, put x, in place of k, put y. So, we will get x square minus y square equal to a square minus b square. So, this becomes the equation of director circle. So, if you notice this method involves significant degree of simplification. Now, here if you mess up somewhere, even if you do one small mistake, it is going to create lot of troubles, because going back and checking is going to be again hectic task, because the terms are big. Okay. But there is a faster method. What is it? By using the separate forms idea. Okay. So, let us also do it using the other idea. So, this is method number 2. Okay. So, how do we do it? Let the point be, which point? Of course, locus point, okay, be h comma k. If the point is h comma k, it has to satisfy the equation of the tangent. What is the tangent that we are taking? Y equal to mx plus minus root of a square m square minus b square. So, again I keep saying, do not remember those direct formulae, that quadratic equation and all, that we will derive directly. Okay. So, when I take mx to this side, what do I get? K minus mh, also I am substituting the point, equal to plus minus root of a square m square minus b square. Now, we have to square it. So, what do we get? K square plus m square h square minus 2khm equal to a square m square minus b square. Now, take m square together. So, m square into we get h square minus a square minus 2khm, there is only one linear term, and then the constant term, which is k square minus b square plus b square equal to 0. Now, we want these two lines, we want these two tangents to be perpendicular. That means, we want the product of slopes to be equal to minus 1. So, when I solve this quadratic equation, I am going to get two roots as m1 and m2. Now, because I want perpendicular lines, I will put m1 into m2 equal to minus 1 directly. So, what is the product of roots here? It is going to be m1 m2 equal to k square plus b square by h square minus a square. This must be equal to minus 1. So, further when I simplify this, what do I get? K square plus b square equal to minus h square plus a square. Now, take all variables to one side, constant to the other side. So, what do we get? H square plus k square is equal to a square minus b square. Okay. So, we got the same locus. But out of these two, which method is psychologically simple? Psychologically, this method is lengthy, but this method is psychologically simple. But conceptually, both methods are same, but the earlier method has conceptually less steps. So, just get SS11 equal to S1 square, put coefficient of x square plus y square equal to 0. Okay. But here it is a different task, we have to understand the process. If we do not understand process, then second method may create troubles, but this is algebraically simple method. Okay. So, this way we can derive the director circle. Okay. Also, if you understand the method, we can also use this method in solving many other questions, which you will see in the examples. Okay. Come on, make a note of this. This page also. Okay. So, now that we got the equation, there is a simple discussion that is required on this equation. So, let me just do it right here. I will erase this and I will do that discussion. So, for this curve x square by a square minus y square by b square equal to 1, we got the director circle as, so if I am writing DC, understand that it is the director circle. So we got the director circle as x square plus y square equal to a square minus b square. Now what is the conjugate of this? The conjugate is y square by b square minus x square by a square is equal to 1. That is the equation of the conjugate hyperbola. Okay. So now coming to this, I will first discuss this and then I will explain the connection. Here if you check the radius, what is the radius? Radius is root of a square minus b square. So radius has some troubles here, because under a root, the value under the square root may sometimes be negative. So what if b is greater than a? Then r becomes imaginary. That means circle does not exist in real space. That means director circle does not exist for the hyperbola. So earlier we have learned that for any curve director circle is possible. No, it is not. For hyperbola of this kind, director circle does not exist. But for any circle, director circle exists. For any parabola, director circle exists, which is the directrix only. For any ellipse also, director circle exists. But for any hyperbola, director circle does not exist. So let us look at those cases. So here there are total 3 cases. One is a greater than b. If a is greater than b, what is a here? A is the semi-transverse axis, b is semi-conjugate axis. Now in hyperbola, there is no condition that transverse should be greater than conjugate or conjugate should be greater than transverse. There is no such condition. So a can be greater than b, a can be greater than b, a also can be equal to b, a can also be less than b, all are possible. So in all these possible cases, what happens to the director circle? So here director circle exists, okay, and radius is going to be a positive number. And here in this case, director circle is a point, because when a is equal to b, radius becomes equal to 0, and then director circle becomes a point circle, which is the point which is center only. So this point is nothing but the center of the hyperbola. So what happens when a is equal to b? A is equal to b is the special case of rectangular hyperbola. So that means for rectangular hyperbola, director circle is only a point. That means there is only one point from which you are drawing perpendicular tangents, and that those tangents also become the asymptotes of that rectangular hyperbola. Okay? And those tangents are also happening to be the tangents which never touch the hyperbola. Okay? So here for a equal to b, director circle is just a point. Now for a less than b, what is the case? For a less than b, director circle does not exist. DNE means director circle does not exist. DNE means does not exist. Okay. So here we have understood the all possible cases of existence of the director circle. Now let us compare this analysis with the conjugate hyperbola. I will do that in red. So for all these 3 cases, what happens to the conjugate hyperbola? Okay. Now conjugate hyperbola and the original hyperbola both are going to have same asymptotes. Of course you know that. Okay. So now let us analyze the nature of the director circle. But for conjugate, what happens is the nature is exactly reverse. Okay. So when A is greater than B, director circle for conjugate does not exist. Director circle for conjugate does not exist. Now when A is less than B, it is the same case. Director circle is a point, that point is itself center. Okay. Suppose let us say if I make a statement that there are two mutually conjugate hyperbolas and for both of them director circle exists, it means both hyperbolas must be rectangular hyperbolas, okay, because here the nature is reverse. Okay. So, also in the third case what happens is here director circle exists and the radius is greater than 0. Okay. So, if you observe the nature of the hyperbola and the conjugate hyperbola with respect to the director circle is completely skewed. Okay. You know the meaning of the word skew, it means completely reversed. Okay. It is like transpose. Okay. So, the nature is completely skewed. If director circle exists here, it does not exist there. If it is a point, it is also a point there. If it does not exist, it exists there. So, if I make a statement that for both hyperbolas director circle exists, then it means both hyperbolas must be rectangular. Okay. So, this is one simple idea of comparing the hyperbola and conjugate with respect to the existence of director circle. Now, also there is one more idea. Suppose if I take the angle between asymptotes as theta, if I take angle between asymptotes as theta. Okay. So, to understand this we also need some more space. So, let us erase it here also. So, let us say these are my asymptotes, okay, and here there is hyperbola like this, and here we notice that because it is compressed hyperbola, the conjugate axis is going to be smaller compared to the transverse axis, because conjugate axis represents the compression and the expansion of the curve. This I have discussed earlier also. So, that means if conjugate axis is small, then it is a compressed hyperbola. So, what about the conjugate hyperbola? It is a stretched hyperbola, it is very wide hyperbola. Okay. So, now I will take the angle between asymptotes as let us say this theta. Okay. And for the asymptote, for the conjugate hyperbola, the angle is let us say beta. Okay. So, here we can also pose conditions like this. I am writing this in green. For the first case, theta will be less than pi by 2. For the first case, theta will be less than pi by 2. You know the formula for theta, it is 2 into tan inverse of b by a. Okay. So, if theta is less than pi by 2, director circle exists. If theta is equal to pi by 2, director circle is a point. Similarly, if theta is greater than pi by 2, then director circle does not exist. Now, similarly for this also we can write the theta, but for conjugate hyperbola we should be taking the angle between asymptotes not as theta but as beta. Okay. Theta is the angle between asymptotes of the blue hyperbola. For red hyperbola, beta shall be taken as the angle between asymptotes. Remember this, do not do this mistake. Okay. So, for red hyperbola, beta is the angle, and we know that because these two angles are the supplementary angles, theta plus beta is always pi, it is always 180 degrees. So, coming here, if theta is pi by 2, so definitely beta is going to be greater than pi by 2. So, if angle is greater than 90, it does not exist. Okay. Similarly, here beta is exactly equal to pi by 2. So, director circle is a point. Similarly, here beta is less than pi by 2, that is why director circle exists. Okay. So, this way we can understand the idea of director circle. Okay. So, I hope this is clear. So, you can also make a note of this, you can also make some observations and you can also make your own theory based on your own observations. Okay. Now, this discussion is not there in any book, I have just made it based on my understanding, you can also make it based on your understanding. Okay. So, it is always better to derive your own theory, your own points. Okay. So, come on, make a note of this. Okay. So, can we move on now? So, basically in the part of tangents, what have we covered? These are the list of concepts in tangents. First we started with tangent at a point, that means point is on the hyperbola. Next we went to parametric form, we just substituted a sec theta, b tan theta for x1 and y1. Then we went to the condition for tangency. After we got the condition, we got the slope form. After we got the slope form, we went for tangents through any point. Now, after we have understood this logic of pair of straight lines and also separated tangents, then we went to the concept of director circle, because all these are connected. Now, the reason why I listed all of them together is to show you that these are the only concepts of tangents, that is one aspect. Second is to urge you to prove them on your own. Now, the one who proves all the formulae will remember the formulae. If you do not prove on your own, if you try to copy and try to remember, then you are going to put too much stress on your mind, which is not going to be helpful in exams. Okay. So, if you derive them even after 4 or 5 months, if you want to revise the entire chapter, they come to your mind quickly because you have derived them on your own. Okay. Okay. So, these are all the concepts of tangents, and with this we will close the concepts of all tangents. Now, we will move on to the normals. So, what is the normal at a point? Again, point is on the hyperbola. We have derived this by reversing the coefficients. Okay. So, if we compare this with the tangent at a point form, it was something like this. So, what did we do here? We flipped the coefficient of x, we flipped the coefficient of y, and then we reverse the sign. If there is one plus here, we made it as minus here. If there is minus, we make it as plus. Okay. So, this way we can always derive and connect all forms. Okay. Now, once if you derive only LHS, RHS can be calculated by substituting the point. So, you do not need to remember the idea of RHS. Okay. Now, the same way also we have derived this parametric form of normal. Now, we will go to the other ideas. Suppose let us say we want slope form of normal. How do we do that? How do we get the slope form of normal? To get the slope form of normal, we need to compare this line with y equal to mx plus c. So, let me just do that in the next page. So, ax by sec theta plus by tan theta, this must be compared with what line? Y equal to mx plus c. Okay. Now, we cannot apply the other idea that we used in tangents. Remember, we substituted y equal to mx plus c, we tried to solve for x and we put discriminant equal to 0. That idea we cannot apply here, because here we are not checking at how many points the curve is cutting the line or line is cutting the curve. No, that idea is going to fail here. So, we will try to compare this and this directly and solve for m and c. Okay. Because we are interested in only slope form, so our idea is to only get the value of c. So, how do we do that? Just compare them, compare these two. So, I will convert this into this kind of form and then compare. So, I can write this as mx minus y equal to minus c. So, let me just compare. So, I will get m sec theta by a is equal to minus tan theta by b and is equal to minus c by a square plus b square. This I got by directly comparing these two. That means, I have just applied the proportionality idea. Now, further what am I interested in? Am I interested in m or c? I am interested in c. So, what is the best way of getting c? To get c, we need to eliminate theta also. So, let me just get sec theta and tan theta from here. So, what will be the sec theta here? Sec theta will become minus AC by m into a square plus b square. Again, tan theta will become BC by a square plus b square. And we know that sec square theta minus tan square theta must be 1. So, how do we do that? A square c square minus m square b square c square divided by, basically I am applying sec square theta minus tan square theta is equal to 1. So, here I am just squaring them and subtracting. Okay. So, what do I get in the denominator? M square into a square plus b square. So, what am I getting for c square? C square is equal to m square into a square plus b square divided by a square minus m square b square. Okay. So, that means to get the condition we just need c, and I have got c here. So, I can just substitute it to get the slope form also. Okay. So, it is always easy to compare y equal to mx plus c with the parametric form to derive the slope form of the normal. But deriving slope form of tangent is simple, but deriving slope form of normal is going to be little tougher, but always the parametric form will help you with that. Okay. So, if I want to put c directly, so I just need to take square root and put plus minus sign. So, basically it becomes y equal to mx plus minus m into a square plus b square divided by root of a square minus b square m square. Okay. So, now the way I remember this form is like this. So, we have this tangent form which is y equal to mx plus minus root of a square m square minus b square. So, now the way I remember is like this. Here m square is changing its side, it is instead of coming with a, it is now coming with b. Okay. And that term is coming in the denominator, there is one m in the numerator and a square plus b square is there. Okay. So, this way you can try to connect them and try to remember. Okay. So, it is always easy to map the new things to the already existing old things to remember them. Suppose let us say you are learning very brand new concept today and there is brand new formula. Now, it is better to connect that formula with already existing ideas in your mind so that you remember it for the future. Okay. So, this is called as the mapping technique to remember. Okay. So, we can always use this in any subject, even in chemistry also we can use the mapping of ideas. Okay. So, I will also discuss this mapping of ideas towards the end of the chapter. Okay. So, this way we can derive the equation of the slope form of normal to the hyperbola. Okay. Come on, make a note of this. Okay. So, the next concept is normals through an external point. So, through any external point, what is the best way to find the normals? Now, not just an external point, we can also find it through internal point also. It can be any point. Okay. So, because normals are possible through points which are interior to the curve and for the points which are exterior to the curve also. Okay. So, how do we do that? It is the same process. Put the point in slope form, solve for m. Here we may not get 2 values, we may get 4 values, that we will check a little later. So, we may get 4 values of m depending on the situation. And then after we get the values of m, we can put them back in the, okay, so this is not tangents, it must be normals. Okay. We can put them back in the equation to get the normals. But of course, you understand why tangents came here, because when I was making the PPT, I have just copied the same slide and changed tangent to normals. Okay, but that happens. Okay, so here, if there is a confusion of plus minus sign, then you can go for the point slope form always. Okay, so let us just observe it. Okay, so if the point is, let us say, h comma k. So here the point is constant. I have to put that in y equal to mx plus minus c into a square plus b square divided by root of a square minus b square into m square. Now when I put it, what happens here? So I get k minus mh equal to plus minus c into a square plus b square by root of a square minus b square m square. Now further, when I square this up, what do I get? K minus mh whole square into a square minus b square m square is equal to c square into a square plus, sorry, here it must be m. Okay, so we did a mistake here, this must be m. So here it is m, and here also it is m, here it is m square and whole square. Now if you look at this, LHS already has degree 4. So when I simplify this, I am going to get 4th degree equation in terms of m. Now when I solve for m, maximum number of roots I could get are 4. So that means 4 normals are possible. So we can say that through a point, maximum of 4 are possible. But through every point, we do not get all 4 normals. Some points may give only 2 normals, some may give only 1 normal. It may change depending on the situation. So, but we can say that we may get at max 4 normals. Okay. So, at max 4 normals are possible. So, after we get the slopes here, let us say the slopes are m1, m2, m3, m4. Then to get the equation of normal, we better use this form. Okay, because because there is no confusion of sign here, we prefer this instead of directly putting the values in this equation. If we put the values of m back in this equation, there is going to be confusion of plus minus sign. Now if you have 4 slopes here, and if all 4 are different, and by substituting all 4 here, you may end up with 8 equations, but that is not going to help you. So hence we try to use this form which does not have confusion of sign. Okay. So this way we can find normals through any point. Okay. So with this we can conclude the concepts of normals. Come on, make a note of this. Okay. So here in normals, what we have learned? We started with normal at a point, and then we went to the parametric form, and then we went to the condition for normal, and then we went to the slope form of normal, and then we completed this normals through any point. Okay. So with this we can close the concepts of normals. So we have learned tangents in depth, we have also learned normals in depth, and throughout this discussion we also understood what is the pattern, what are better methods, what are lengthy methods, and what are smarter methods. We have learned all of them. So now we will start with the problem solving. So in today's lecture we may not be able to cover as many questions as possible, but in the next lecture we will start with that problem solving, and probably after we get time we may go to the chords in the next lecture. But in today's lecture we will try to cover as many problems as possible. Okay. Come on, let us start. So there is this line, this touches the hyperbola, then find the lambda. So what is the question on which concept? Now list down all concepts: condition for tangency, slope form, tangent at a point, tangent through any point, parametric form, director circle. These are the concepts. which concept are we touching here? We are touching the condition for tangency. So, how do we get it? By directly comparing this with the point, or we can also directly write this in form of y equal to mx plus c and get the condition. Okay. So, either way it is possible. So, how do we do it? We can also do this using a different method. So, I will explain both methods here. Okay. So, let me just convert this into y equal to mx plus c form. So, what do I get? 5y equal to minus 21x plus lambda. So, y becomes minus 21 by 5 x plus lambda by 5. And this equation when written in standard form looks like x square by 232 by 7 minus y square by 232 by 5 is equal to 1. So, this becomes my a square, this becomes my b square. So, just put the condition. What is the condition? C square equal to a square m square minus b square. Now, I want to find lambda. Lambda is coming only in C. So, I can just focus on lambda by 5 whole square. This is equal to, what are we getting here? A square, which is 232 by 7 into m square, which is 21 square by 5 square, minus what is b square? It is 232 by 5. Now, let me just simplify here. So, I can take 232 by 5 square common, then what do we get? 21 into 21 by 7 minus 5, this is what we get here, right. Okay. So, now further how do we simplify this? 7 can get cancelled here, 21 into 3 minus 5, 21 into 3 is going to be 63 minus 5 is going to be 58, and here we are getting 58, and here there is a 5 square. So, 5 square can get cancelled with this. So, I will not simplify this 1 by 5 square, but I will simplify this 232. 232 can be written like this. Let us say if I divide this with 4, what do I get? I get something like 58. Okay, very nice. So, here we can write this as 58 into 58 into 4, very nice. So, 5 square is getting cancelled, I can write lambda as 58 into 2, that is the square root. Now, this is the concept of 7th standard that I still remember. When I was finding square roots, when we find square roots, what do we do in 7th standard? We first prime factorize it and try to collect the terms. Okay. So, that is faster method for finding square root. So, this way we got lambda, which is 116. So, here we can say that option 1 is right. Now, what is the other method, which is the better method? We can also do it like this. So, we got a as this, okay, and we got a square as this, b square as this. So, we can just take them as a and b and try to compare them by taking a point. Either you can take sec theta, tan theta, a sec theta, b tan theta, or you can take x1, y1 also, it does not matter. Okay. Suppose let us say if I take any point, okay, so that is little bit long, because we are going to take lot of time here. Okay, so this is let us say x1, y1, I have taken a point, of course point has to satisfy hyperbola. So, there is that condition, I just kept it there. Now, I am interested in finding the tangent at x1, y1. So, how will that equation look like? 7xx1 minus 5y1 equal to 232. Now, what is the given equation? It is 21x plus 5y equal to lambda. Now, compare both of them directly. So, we get lambda by 232 is equal to 21 by 7x1, and that is equal to 5 by minus 5y1. So now here cancel as many as you could, okay, and get x1 and y1 only in terms of lambda. So here x1 is coming out to be 3 into 232 by lambda, and y1 is coming out to be minus 232 by lambda. Now just put these two in this and get the value of lambda, okay. So how do we do that? 7 into 3 square into 232 square by lambda square minus 5 into 232 square by lambda square equal to 232. Fortunately, 232 is getting cancelled, and we are getting lambda square is equal to 7 into 3 square into 232 minus 5 into 232. This way also you can calculate, okay. So we can either start with the point x1, y1, or we can also do it like this, okay. Come on now, can we move on to the next question? Okay. So find all possible values of m if this line is, for all possible values of m, if this line is a tangent to some curve, find that curve, okay. So this is straightforward, this is based on the condition only. So if you recall, there is only one equation of the curve which will give minus sign in this, okay, which is the hyperbola only. So for example, if you look at the circle, you get circle as this. If you look at parabola, it has a by m. If you look at ellipse, it has root of a square m square plus b square. Only ellipse has minus sign here, only hyperbola has minus sign there. So it is easy to check which curve it is going to be. If there is minus sign here, definitely it has to be hyperbola. That eliminates these two options. And then further, it must be a square m square minus b square. So a square must be 9 and b square must be 4. Now for which of these two curves a square is 9? For only this curve a square is 9. So that way we can solve this question. This is, I think, very easy question, okay. So find the point of contact of this. What is the best way? Again, I have helped you in the last question also. We can take the point as h comma k. If the point is h comma k, how do we get the tangent? It is s1 equal to 0. So 3xx1, so here x1 is basically h, 3xh minus 4yk, this must be equal to 11. So let us try to compare this straightforward with the given line, which is 9x plus 8y equal to 11. So if we compare these two, what do we get? 3h by 9 is equal to minus 4k by 8 equal to 11 by 11. So 11 by 11 is anyways 1. So if I equate the first one with the 1, I get h equal to 3, and if I equate this, I will get k equal to minus 2. So this way we can find the point, which is of course the option 1. So here if you remember, if you try to compare this with this idea, Lx plus my plus n equal to 0, if it is tangent to the hyperbola, what is the condition, what is the point, minus a square L by n, minus b square m by n. So those formulae you don't need to remember, those are unnecessary time waste ideas. So the best idea is to take the point as h comma k and compare it with the equations. This way you can get it even faster, okay. So with this we will close today's lecture. We will meet again in the next lecture with more problem solving skills and other concepts. Until then, have a great learning day. Learning shall never stop.